This is a music box, and it has some similarity to the way we were using the modulo. In the last episode we had a variable, we can call it n, that was increasing over time. 0, 1, 2, 3, 4, 5. We could imagine that this cylinder here rotating, it has also an increasing rotation, an ever increasing rotation. It's going this way. When we used here n modulo 4, for today's example we could say 50, then we have a number that goes up to 49. Here would be 48, 49, and then it jumps back to 0, 1, 2, 3. So this expression here, n modulo 50, is giving us numbers between 0 and 49, and then it goes back to 0, and again 1, 2, 3, 4, 5, all the way up to 49. So it's like a circle. It's like this cylinder. This cylinder is playing some notes over and over again. It plays a short song, and then it starts again, and then it starts again. Imagine we count the millimeters here for this cylinder, and we give them numbers. This could be 0, 1, 2, 3, and all the way around the circle. Maybe it would be 47, 48, 49, and then again 0, 1, 2, 3. So we could use this expression to know if we are at a certain position in this cylinder. We could say if n modulo 50 is, that's equal 0, then do something. This 0 could mean, are we at this location here? Maybe this location, the number 0, has 4 notes here. So then we could say play note 2, 6, 18, and 23, for example. On location 1, there's no notes here, it's empty. So we don't have to do anything in that case. And again, for case 2, when n modulo 50 equals 2, then we could play these other notes. So you can see how this music box is similar to our expression. We can achieve the same effect. We can have something that cycles and gives us some kind of repetitive event. Let's make a program where there is such a repetitive event. For example, a heartbeat is a repetitive event. It's a bit tricky to draw a heart, so I'm gonna draw a circle beat. A circle is gonna represent our heart. And you can see here this basic setup, just a size, no stroke, smooth, and I'm erasing the screen every time. For now, I'm gonna just draw an ellipse on the middle of the screen, and it's gonna be the size 50-50. So if I run this program here, we have the circle, but it's not moving, nothing is happening for now. I'm gonna convert the size in a variable, so I'm gonna say here c size for both width and height. C size, and I'm gonna declare this at the beginning. Int C size is 50. So now the program does exactly the same. The only difference is that we have here a variable. Now let's add another variable here. It's going to be called grow. I'm gonna set this to 0 at the beginning. Grow is gonna indicate if this size is growing or is it getting smaller. Here at the end of the program, I'm gonna write C size is C size plus grow. Because grow is 0, nothing would happen yet. If I run the program, it still looks like the same. But if I type here a 1, now we have a growing circle. Or if I type here a -1, then we have a shrinking circle. Let's leave it at 0. And now we need some kind of event that would change grow. And for creating this event, what I'm going to do is to use the modulo. So I'm going to say here, if n modulo 60 is 0, then do something. We need to declare this variable and increase it over time. So I'm going to type here int n is 0. And at the end, I will just increase n. N is n plus 1. Okay, so now n is cycling through all numbers, starts being 0 and it goes slowly towards infinity. And every 60 frames, this will be 0. So when n is 0, this expression will be true. When n is 60, when n is 120, 180. What should we do then? And I'm gonna set here that grow is 5. So this will trigger a fast growing of this circle. Now we need a way to stop. We don't want the whole screen to become red. So at this point, the circle might be growing, so I have to check what's the size. If it's too big, then you better stop. I'm gonna say here if C size is greater than 80. If we are starting with 50, so I think 80 should be already quite visible. So if C size is greater than 80, in that case, then make C size equal to 80. So don't let it grow bigger than that. Then let's set grow to -2. See, grow used to be 0. Then at some point we made it equal to 5. So the circle started growing. When it grew enough, when it had the size of 80, then we said stay there, use this size of 80, and now start decreasing. Now the circle will start getting smaller. We have limited the circle to 80, and now we start subtracting 2. So it's going to be 78, 76, 74. So now again, we need another if statement to stop shrinking. We don't want it to become invisible. So I'm going to say here, if C size is less than 50, I don't want it to get smaller than 50. So I'm going to say C size is 50, and then grow is 0. So it will stop shrinking. So I think this should be the whole program. Let's run, see what happens. So there we have our beating circle. So let's review the program. Initially, we're setting 3 variables. One is called C size, and it's holding a value of 50. Grow is 0, and n is 0. And we define here some initial settings. This is gonna only run once when we start the program. We set the size of the screen, we remove the borders, we activate the smooth mode, and we set the red fill color. This is red, green, and blue. And after that, the program is gonna be calling the draw function continuously, time after time after time. Every time it's gonna erase the screen and then execute this series of if statements, draw an ellipse, and then it's gonna maybe change the size. It's adding to the current size the variable grow, but initially it's 0, so it's not adding anything. The size is staying at 50, and n is increasing each time. N is 0, 1, 2, 3, 4, 5, 6. Sometimes n modulo 60 is 0. This is happening when n is 0, when n is 60, when n is 120. When this happens, we change the variable grow and we make it equal to 5. These 2 if statements initially will not run because if the size is 50, it's not greater than 80 and it's also not smaller than 50. But okay, let's assume now the circle is growing. It's going to be 50, 55, 60, 65, 70, 75, 80, and then it's going to become 85. When it's 85, it's going to be greater than 80. So then we are going to limit the size to 80, and then we say now start shrinking. This will still be false, because if the size is 85, then it's not less than 50. Okay, so now it's decreasing 2 pixels at a time. So 78, 76, 74, 72. This expression is no longer true. So these 2 lines will not execute. Now it's less than 80, and it's also greater than 50, so these 2 lines will not execute. But at some point, it will be 54, 52, 50, 48, and then that will be true. 48 is less than 50. So in this moment, make it equal to 50, and now stop growing. And it will stay like that for a while with size 50 until n modulo 60 is again 0. We can change the rate of our circle beat, changing this value here. If we make it higher, then it's going to be slower. Now it's more relaxed. It's probably watching TV. And if we type here 20, now it's going quite fast. Definitely it's not reading a book. I think it's running at the moment. So we've seen one more example of how we can use the modulo to trigger some events once in a while, regularly. And let's see more examples in coming episodes.